Thanks for joining us today, guys. During these next couple days, we're going to be doing training on electricity and motors. Before we really dive into all of that, what we're wanting to do is give you guys a good foundation. The goals for these couple of training sessions is ultimately going to be able to give us the confidence to work safely around electrical systems. In order to do that, we need to be able to understand the terms and parameters that is used to describe electricity. So I want to give you a working and functional knowledge of that stuff. This PowerPoint is mainly going to be focused on the terms and parameters of electrical systems, again, because that's going to play back into our understanding of how to work with these systems safely. So let's start by talking what is electricity. We're going to talk about what is electricity. We need to know what an electron is. Ultimately, an electron is part of an atom. Right here on the screen, we have a very elementary representation of a carbon atom. And the thing I want you guys to note here is that we have electrons. These are the green balls. They are negatively charged, and they are on the peripheral of the atom. That means that they are loosely attached to the atom nucleus. They're negatively charged and they're loosely held together. Now we're talking about charge, negative charge. I think we all remember this, but objects with a like charge are going to repel each other. Okay? So that means they're going to exert a force on each other that is going to push each other away from each other. They don't like to be next to each other. The opposite of that would be opposite charges. They attract each other. But we're dealing with electrons, and electrons have all the same negative charge. So they're going to exert a force or pressure on each other, pushing them away, wanting to make them flow away. All right, we've got a photo of a cute little kid right here. Can anybody tell me what's going on? Why is his hair standing up on edge? Well, if we look down at the lower left corner of this photo, you see this metal ball right there. That is called a Van de Graaff generator. A Van de Graaff generator basically pushes electrons onto that metallic dome right there. Creates static electricity, pushing those electrons, forcing them to concentrate on that dome. The electrons, they're all negatively charged, as we spoke about. That means they're repelling each other. They're exerting a force on each other. They want to get away. So when this kid places his hand on that dome, those electrons are going to start to travel up the boy's arm as they're trying to get away from the high concentration of electrons on that dome. They're going to continue to travel up his face and into his hair because it's trying to get as far away from that dome as it can and far away from each other as they possibly can. Now you'll see that this kid's hair is standing up on edge. What's going on there? Essentially, these electrons move out to the edge of his hair, but other electrons have done the same thing. And so how can they get further away from each other? By overcoming the force of gravity and sticking the hair out, becoming as the greatest volumizing as they possibly can. Another image that might be familiar with northerners is a spark leaping from your finger to a doorknob, light switch, maybe your dog's nose, unfortunately. That is happening because we've developed a concentration of electrons on your finger. And those electrons are exhibiting a force, a pressure on each other. They want to get away. However, they don't have anywhere to go when you're just standing in the middle of the room. But as you approach an object that is grounded, your doorknob, maybe your big sister, something else, these electrons are going to jump through that object and go down to the ground and creating a flow of electricity. So what we have here is we have a lot of electrons that have created a pressure as they're trying to get away from each other because similar charges repel each other. They create this pressure. They're trying to get away from each other, which generates a flow of electricity. Okay? Now, let's talk about metal, because we know that metal is what we use in electrical systems. We use metal wires, metal components, and that's because metal has a special property about it with its electrons. You can call their electrons delocalized valence electrons, okay? What that means is these outermost electrons out here are very loosely held onto the atom. They're held into the material as a whole strongly, but they're allowed to move between the different atoms. So they're delocalized. Now, if we were to apply an electrical pressure over here to these electrons, examples of applying an electrical pressure could be a solar panel, or it could be an alternator from a generator, a battery connecting to the national power grid. That creates pressure on these electrons. So we have a field right here that's applying pressure onto these electrons. It's a negative field that's pushing these electrons away. Now, as these electrons move away, they're also pushing the other electrons away. And all of the electrons within the entire length of this metal bar begin to flow. Now, in electrical systems, we used wires, and we know that circuits have to be completed. It means the return path to the backside of that electrical pressure has to be complete. So what I have drawn here is, again, an electrical pressure. This could be a solar panel, a battery, anything that generates electrical pressure. And it makes these electrons move through this bar. And again, they keep acting on each other, and they're going to flow. Just like water particles, molecules of water can flow in a channel if you have a pump moving that water, creating water pressure. These electrons are going to flow. And since these electrons here have already moved forward, these electrons in the back can move forward into their place. And we're going to get a continuous flow of electrons so long as we have that electrical pressure being applied to this wire.